So everybody got a copy of the Lab 8 work cell on their thumb drive, right?
Yes.
Okay. So Tim, you can get that whole work cell off the student drive, okay, and put it on your thumb drive. So what we're going to do for the test and also for the final exam is we're going to use this work cell that you've already got. But what we're going to do is we're going to add some additional models to it, and we're going to utilize some inputs, outputs, and we're going to come up and make the program loop. Okay, any questions so far? So this will give us everything between Lab 8 and Lab this, especially this lab, will give us an insight of what's going to be on Test 3 and also what's going to be on the final. The final is basically the last part of Test 3. So what we're going to do during the final, is we're going to build the work cell, we're going to build our program, we're going to add stuff to the work cell, really. Okay. And then we're going to, for the final, we're going to write the program. And then what we're going to do for the final itself is transfer it to the robot, run it, everything over there that we did, kind of like test 2, where the test was basically split up into 2 parts. Huh? What's that? No, not your thumb drive. You left the hardware key in there. There wasn't a thumb drive in there. Yeah. No, that's where it was. But,
you say you left your zip drive in the computer?
no.
You took your dongle.
Yeah, that's the only thing that was in there. And it's not in the box. So what we're going to do to this one is we're going to add the model for a block, but you don't hardly see these anymore, these nice wood blocks. Okay. And it's a square, so all we got to do is measure one side, and it's 30 millimeters square. So I've measured it for you. And what we're going to do is we're going to position it in the box. We're going to bring it down. We're going to pick it up. There's another lab in there on my printer. Probably needs to be stapled together. And then we're going to set it back down. Pick it up, come up to our start position, and then we're going to set the block back down and open up the grip. And we're going to make the program loop. So we're going to wait on an input. So that means the program's going to come down and install. We're going to learn how to use the force on our simulation, because if we're waiting on an input, your simulation doesn't have an input on it, right? You understand that? So we've already looked a little bit about that, where you can actually simulate an input. So we're going to use the Lab 8 work cell. But all we're going to do is add some models to it. And we're going to, once we add our model to our block, then we're going to write a program. Now in your simulation, you have to understand the block is not going to move. Right now, y'all don't know how to transfer models. I could show y'all, but it doesn't mean anything to that guy over there, right? You understand that? So here's lab A. And what we're going to do is going to put a box in here. So what's the size of the box? It's in your lab there. Somewhere. So we're going to put a box. We're going to attach it to floor 2, not floor 1. In fact, it's already there. Sorry. All I got to do is unhide it. Okay, so we got a box. This is going to be the same size as the cardboard box that we've been using all along. Okay. And then what we're going to do is we're going to create a model for the block. I just gave y'all the dimensions on it. It's real hard. Huh? 30 millimeter square. So your length, so your width, your height, and your length is going to be what? 30 millimeters. Okay. And then where does it say we're going to put it in your lab? So see my block? Okay. So where you'll attach it to floor 2. So you're going to put your box on floor 2. So floor 2 will be the parent. Y'all got a tendency of making stuff part of the floor. This is not going to be part of the floor model. It's going to be attached to the floor, right? You understand? So we'll make the floor. So somebody did this on the last test, where if I went in here for the model floor, they put the box as part of the floor. So if you put anything right here, it's part of the model that you're in, right? You understand? If we're going to attach it, we call it making the parent. So the floor 2 is going to be the parent for the box. And then we're not going to make the block part of the box. We're going to attach the block to the box, right? You understand that? So every one of these will be individual models. Y'all understand that? Yes or no? So when I come up here and look at the box, there's only thing in there is a wall, is a box. If you put the box for the block on this, it is part of the box. Well, you couldn't move it if I showed y'all the commands to change the parent, the whole dang thing would move, right? You understand? So it's an individual model that's sitting on the. So this block is not part of that box over there. It's an individual model. But we got to set it on something, right? You understand? And we call that the parent. Which is the orange box. And the orange box is not part of the floor. We go over there and I can take that box off and put it down, right? You understand? So if you made this part of the box and you tried to make the box, if you tried to hide the box, what's going to happen? Your whole floor is going to disappear. So this is an individual model, but it's got a parent. It's sitting on something, right? You understand? So what's the box sitting on? Well, it's sitting on floor 2. So this is floor 1. This is the original floor that the robot's sitting on. We call this floor 2. It's the floor that we added, right? You understand? The box is going to sit on the floor, so the floor is going to be the parent for the box. And then the box is going to be the parent for the block. Okay, y'all understand? Okay.
And the orange box is the child.
We don't call it child.
The offspring of the floor too.
Yeah, you'd say that. But when you go up here and change it, so what we have the ability to do is when I go to the attribute, is one thing I can do is what? Change the parent. And we have the ability to do that, by the way, with an instruction. Y'all don't have to do it. But I'll show y'all some of the other things that we can do with MotoSim, where I can literally have multiple models. So I can have a model with the gripper closed, and I can have a model with the gripper open. And I'm going to tell my program to hide the gripper open and display the gripper closed. So to us, it looks like it does what? Looks like it closes. And then we have the ability to, inside the program, to reset the parent. So what I could do is I could take the block, and then I could transfer it to the tool. and it would appear that the robot is actually picking up the block. Now, that's just for MotoSim. It's not gonna, just because it does it in MotoSim don't mean it's gonna do it over there, right? You understand? So our block is gonna stay stationary. Do I have it in the right spot?
Custom all the box using block one.
Okay, so this would be it, right? Is that the right place? Okay. So what are we gonna do once we get it there? Okay, so we know how to open a job, so we're gonna come up here and do what? We can go to select a job. You can go through robot, which takes a little longer, but there is an icon on here, right here, that says what? Select job. And then I'll come up here and give it a what? Yeah, give it a light and give it a name. And y'all gonna give it with y'all's, and then I'll say what? Okay, so there's our job. When I look at my controller, there's my job, and I'm calling it Lab 9. Okay. Then what's the parameters for the job? Okay, so what we're going to do, so how do we add instructions? So the only instruction that's available through the teach pendant is the move instruction on MotoSim. Now over there on the actual MotoMan, you would hit inform list and it would show you all the commands. And what's nice about that is it sticks the commands using the right syntax. And then what you got to do is you got to go in there and modify the instruction with what you want the instruction to do. MotoSim, the only instructions that are built into the controller are your what? Move instructions. So what are we going to do? Yeah, so what we'll do is we'll hit no op, right? Yeah, well, it highlights it automatically, so you don't get, so I'm going to put asterisk, and then I'm going to put what? Star. Okay, are you okay? And then what I want to do, I don't want to replace my no op. I just screw up, I add. So what we've done is we've stuck a a label in there. So what we're going to do, what we talked about the other class, is we're going to do a jump label instruction, which is also in your lab where you're supposed to write the syntax. Okay, so there's our star. What's the next thing we want to do? Okay, so what I'm going to do is I'm going to click on position, and we're going to set a what? An angle. So I'm going to go to what? Join angle. Okay, and we're going to do what? Okay, B is negative 90. So all I have to do is put negative 90, hit enter. Okay, and L is 90, which is already there. Okay, and I'm going to teach this home position. What does it say I need to do with this home position? Joint move. Fastest possible speed, 100%. Okay, the highest possible position level would be an 8, right? Okay, but that don't teach it. That just sets up my default. What do I need to do now? Hit add, right? And enter. So there's our first point. Okay, guys, what else do we need to do now?
Add a weight in hashtag.
Okay, so I'm going to add a weight instruction. That instruction is not available right here, right? So what I'm going to do, I've highlighted the instruction I want to put it before, right? Y'all see what I'm going to do? What I'm going to do now? I'm going to double click, and I'm going to add a what? Weight, right? Space. What else does it say?
Oh.
IN. Open parentheses. 4. Close. Equal on. I think it says no space. Oh, I think this is gonna be backwards. Y'all make a correction. Originally, when we got our work cell in, what you had to do is you had to turn it on. That's right, we're okay. On to open the gripper. We want it to turn on to open and off to do what? Close it. Okay, so this is right. So what am I going to do? Add. So there's my weight. Now what we're doing is we're giving the robot, so what we're doing is we're waiting on an input. Input what? Number 4. Okay, so what are we going to do next? Teach a staging spot. Where? Okay, so we're going to go down to the block. The problem is, though, I'm going to have a little problem now, because what we like to do is we like to use OLP. But the problem is, if I come over here and try to click on the block, okay, so what we got to do is we need to hide this glass right here, right? Y'all understand that? Yes or no? Because I can't get to it, because every time I come over here, I'm going to click on the what? On the glass. So how do we hide it?
Right there.
Okay.
To the left. Oh,
So we're going to point to it, click on it, and we need to make a note, because these things are hard to find. And it went into the CAD tree to what? Class 1. Class 1 is attached to column 2. So somebody make a note to that. Remember, we had a little problem finding it last time. So what I'm going to do, I'm going to double click on it, right? Oops, no, I don't want to do that. I'm going to right click, put what? Model attributes, right? I'm sorry, hide C, and what am I going to do? Hide it. So that model now I can come over here and I can use OLP. So y'all know where the model's at. Y'all got any questions? Yes or no? You want me to do it again?
does that say glass B?
It says glass B, yeah, because we got so many glasses. I wanted to call them glass, so I labeled, I think, A, B, C like that when I did the models.
Right click, with the attribute.
No, we right click and go to what, Kathy? Hide C. Now we'll put it back up there, so now the model's there. You can't see it because it's glass, right? And how do we change it? We could change the opacity, but what we usually do on this is leave this opacity real low. Right? Y'all understand? So I have it set to like 0.5, which I had it set to 0 a while ago, so it don't even look like it's there, but it is. So that right there, you can see it. Okay, so I want to hide it. What do? First of all, what I'm going to do is I'm going to come up here. Let's close everything out. I'm going to come up here where it says select model, which is this guy looks like a finger, right? You understand? I'm going to select that. I'm going to come up here and I'm going to click on the glass. What did it do? It automatically went down to that model in the CAD tree. The problem is, it's when it's hid, I can't click on it anymore. So what we did was make a note that this is in what?
Oh, attached to column 2.
Well, yes, it's attached to rail 4, column 2, glass B1. So we gotta get this whole line right here. So column 2 is attached to rail 4, which will be one of these side rails. Okay, so I'm gonna hide this. What do I do to hide it? Right click, hide C, and hide the model. Okay. So now when I come over here, now I can use my OLP. I thought I could. Well, I gotta turn it on. I know it turned off. Are we okay? Any questions? Yes or no?
What is the oil?
Move to another computer. I know you like that computer, but it definitely, your programs work on mine, so it's got to be something with that one over there. So That's what I would recommend, or not use OLP. It's your choice if you want to sit over there. This is going to be pretty hard not to do it, because what we're trying to do is we're trying to center it on this block. And is it going to be centered? No, it's not going to be centered because we're putting the tool center point on the vertex. So it's not centered. I don't know. Let's see if we can do it this way. Let's go back to here. And let's see if we take off vertex and put center. If we come over and click this, if it's going to center on the box or center on the line. Yeah, turned off. But don't get close to the edge, because if you get close to an edge, it's going to try to center on the edge. But we didn't tell it. We took off what? Yeah, took off vertex, took off edge, and you just say center. So it came in center of the model. Now if we roll this thing around, we'll see. Oh, crap, Rich. Hopefully we'll come over here and
Not on the edge, not right.
it's centered on the edge. It didn't center on the center. We'll try it again, see if we can get it to center the block. Okay. So be careful, because notice I got closer to the edge, so what did it do? It centered on the edge. So just roll it around and see if it's centered on the block. Looks pretty good, doesn't it? Real good? Real good? Okay, so what do we need to do now? I don't want to teach it right there. What does it say? 50 millimeters above the top of the block. Okay, guys, tell me what I need to do. Go to position. Yeah, go to robot. G. Subtract 50 from that. What am I going to use? 43.5. There it is right there. Pretty easy, huh? Okay, we got to teach it. What are we going to use?
You gotta come down to the after the
We hadn't taught this point yet.
weight.
Oh, I see what you're talking about. Yeah, we're okay. Okay, so this is where y'all ran into problems. Y'all started just adding instructions without setting up, changing the defaults for the instruction, right? Some of y'all had that problem. So I think we're going to use the fastest speed, and we're going to go to the lowest position level, which would be 0. None is not the lowest, right? So don't say none, because that is no position level at all. And what does the Motorman robot do? Well, it rounds depending on the speed. So you're not controlling that point anymore. You're letting the controller do it for you. Okay, so what are we going to do here? Add. Okay. What's the next thing we want to do? Okay, so we're going to open the gripper. Okay, so what are we going to do? I'm going to come up here. Where do we want to put the out? We're going to use an output command, because the gripper is connected to an output. I'm going to do what? I'm going to double click right here. Okay, on the last move, and I'm going to put what? D, out, right, space, OT, pound sign, open parentheses, 2, close parentheses, got to put a space in there, I believe, space, on. So that means we turn it on to open the gripper. We turn it off to close the gripper. Now, while we're doing that, originally when we bought the robot, they had us turn it on to close the gripper. So you'd go over there and something would be in the gripper, and if you hit the dead man switch, or if you came over and turned that controller off, what would it do? It'd drop whatever it had.
Is that supposed to be equal on there?
I don't know. I don't think so. I think that's what Huh?
Okay, but, all right, and, oh, that was a weight instruction. Yeah,
That was a weight instruction. And the syntax for the in and the syntax for the out are different. So I don't know why they did that, but it is. So up here, if we're doing an input instruction, so this is the input instruction right there, by the way. So we could bring in an input port and use it for something else, right? You understand? Here we're telling it to wait. We're telling the program to wait. But for some reason, Inform 2 decided to put an equal on the input instruction and not use one on the output instruction. Why'd they do that? Heck, I don't know. But we got to have the right syntax, right? Okay, so what are we going to do? Add the line. Now we got to tell the controller to wait and give time for the output to respond. So what we've got is we got a program that's running. And what would happen is as soon as it did that, it would drop down to the next move instruction. But we need to make that dang controller pause and give what? Give it time. So we're going to put a timer. What's the syntax? Phase, right? P equals 1.0. And that's a 1 second delay. And we'll add a line. So now the gripper's open. We pause the robot so it doesn't go down and collide with our block. What are we going to do now? Okay, guys, tell me what we need to do. I'm going to go back to OLP. I'm going to come over here, set it up to go to the center of the block. Let's zoom in a little bit so I can make sure I get on there. Okay, I'm going to click on the center of the block. Oops, OLP turned off. Click on the center of the block. Okay, double check to make sure it didn't line up on an edge. It's pretty good, right? So now we've got it centered this way, right? You understand? Now I need to center it vertical. The block is 30. I want to put it 15. Not subtract, we're going to add. We're going to go more negative. So I'm going to...
Well, all you have to do is singles and add 5. You went 10, the step was 10.
Yeah, the step was 10. Yeah, so what we'll do is we can do it this way. One way we can do it is put it on step 1 and do what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so that's one way we can do it. Or we could come back and do the math. I could add 15 to this. What would that be? Now this is a 5. Don't do all this little garbage over here. Remember, we're dealing with encoders, and sometimes the encoders can't hit it exact. So this would be 93.5. Don't worry about the 2A. And I would come up here and I would add, because if we subtract, it's going up, right? To make it go down, we're going to add. I would add 15 to that. So either way you want to do it. Of course, here it's kind of easier to do what? Just go what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, okay? All right, so we're centered on the block. Y'all see what I did, yes or no? First of all, we did OLP to find the top of the block, and then we did what? Brought it down, but make sure you put your step size on 1 or add 15 to that. Of course, we're going to add a negative 15, right? So don't add. So treat it like an unsigned number. Okay, so what are we going to do now? We're going to teach this move. What are we going to do? What? This is probably going to be a what? Probably going to be a linear move. What speed?
Same speed.
No, I better get, it says a slow speed. Okay, so we need a slow speed. So what do we think we need? What's a good slow speed? 50 millimeters per second? That's pretty fast. How fast did we track around the box over there? We tracked around it at 10 millimeters per second. Did we want it to hit the spot? I'd imagine we do. So what are we going to do? Add this. Okay, so now we're down on the block. Came down real slow. What are we going to do now? Okay, so now we're going to close the gripper, right? So we're going to repeat this command up here. So we're going to say what? D out, what? OT, hashtag, 2, yeah. But now we're going to do what? Turn it off. Add this line. Then what we need to do? Add a time delay, right? TIMER, give the thing time to respond. Equal 1.0. Add. Okay, so now we got our gripper closed. What did it say we need to do? Okay, so that means we got to stage it. So we're going to come back up. How far? Not 50 anymore, up to the staging location. So that's 50 plus 15. Okay. So we got to come up. So somebody subtract 65 from that for me. Y'all understand that? So we're not coming up 50, we're coming up, we went down 15, but we're going back to the staging area that's 15 millimeters above the top of the box. So we could have wrote that down. We could use sync, but here it's easier to me to do the math. So what am I going to put? 43 minus 43.5, which is where it was. Okay, so there we are. Now why didn't the box move? Because well, it don't make any difference. No, the gripper is closed, but the parent of the block is here. The only way I can make this smooth is if I change the parent to where? To the tool center point. So no, it's not going to move. Okay, we're going to teach this linear move, 10 millimeters per second, position level 0. Everything should be okay, right? Double check to make sure what you want. We're going to teach this, and then we're going to send it back to the home position or the start position. Now you can do this whatever way you want to. You can do that sync on, sync off, garbage, or all we have to do is come up here and go to joint angle. I'm going to set this to 0. I'm going to set this to 90, right? You understand? I'm going to set this to minus 90. I'm going to set this to 0, and we're through. No. What happened? There we go. Y'all remember this? Where did we do this? It says PJ start position. So, and it gave you the angles. So you can do the sync on, sync off stuff if you want to. But if you know the position, you don't have to do that, right? So right off there, what step was that where I told you said teach a home position or start position? Well, there's a start position, B. So what I did here is just keyed it in. Okay, what we're going to do here, we're going to use a joint move, 100% and position level, highest position level. Yeah. Okay, so I'm going to teach this. Okay, what we're going to do now? Okay, so now I'm leaving it up to you. So we got several ways we could do that. You know, you could go back here and record what you did for these staging areas right here. I'm just going to use OLP. OLP, click it on the center, right? Then go back up 50, right? One, two, three, four, five. 43.5. But if we'd have recorded that a while ago, it'd have been okay, right? We're going to bring this down using a joint move, fastest position, but we're going to change our position level to what? 0. Okay. And we're going to add this. What are we going to do now? Going to set it back down, right? Don't want to open my gripper yet, because we got to get it down to the top of the box. So I'm going to come down here and use my OLP again. Put it there. Right? I'm going to put it on 1 and come down 15 millimeters. Or you could use the sync, or you could use what you did. You could find that point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like it jumped. $106.5, right? Is that the same thing we used before?
108.
108.
I may have written.
This is 93. This is 93, huh?
93 and 15.
It's an 8.
Yeah.
Yeah, 108.5. Make sure you change your move. So we just went from a joint move. I'm going to come up here and click on move. I'm going to go to linear, 10 millimeters per second, position level of 0, right? Teach this point. What I need to do next, we're setting the block back down. What I need to do next, we need to open the gripper, right? Good, guys. Okay, so we're going to put what? The out, right? OT, hashtag 2, and we're going to do what? Turn it on. Are we okay? And what we're going to do next, we're going to put a timer. Got to give it time to respond. T equals 1.0. Okay, got our gripper open. What do we need to do now? Go back up to 50, right? Go back up through the staging area. One, 2, 3, 4, 5. 43.5. If you wrote those down, all you have to do is what? Key them in. There's our staging area, linear move, 10%, position level 0. That's what we need right there. And we'll add this. Then we need to go back to, then what do we need to do? Well, yes, and yeah, we need to go back home, but our first move is home. So we're going to loop this. So we don't need to send it back to home twice. The start of the program sends it to home. So we're going to put our jump. What's the syntax for jump? Jump, ain't it? Where are we going to? Hashtag start, and we're through. I'm going to add this line. So once the program loops, you don't have, so normally over there, and we didn't have time to get into this in operation and programming. Normally what we did at the end of all our programs is we send it back to start at the end. But we don't have to send it back at the start. What we're doing is looping back to the top, and what's the first instruction? Is home, right? Does that make sense? So let's see how it works. So let's zoom out a little bit. Now what do I have to do to set up collision detection? You're going to have to unhide the thing, right? Set up your collision detection. We're not going to do that because y'all need to start on the lab. But here's the program. We'll come up here and see what it does. Oh my goodness. What's the problem?
You got to force that.
Yeah, we have to simulate the input, right, or false. So where do we do that? So I'm gonna go to Tools, Monitor. What are we monitoring? I/O. Okay.
Toggle whatever.
And toggle, which one are we using?
Input for.
4. And there's a switch over there, by the way, that's hooked up a little switch box that I interface to the robot. So we're going to toggle 4. Now, of course, if it's doing it too fast because of the computer, we're going to go to Tools, Monitor, Play Panel, and what can we do with the Play Panel? Yeah, we can change the speed. Now, you'll never see it actually go back to the start because this is a looping program, and we're using a position level of 8, which makes no difference. Okay, so we're waiting on this again.
Input 2.
Oh, yeah, wrong input. No, input 2.
Yeah.
I guess I could speed it up a little bit. I went too fast. Sometimes it takes a little while to get your playback speed set. And there's the probe. Now, of course, we can't see it pick up the model, right? You understand. Over there on the real robot, it will pick up the model. Hopefully it won't collide. But we'll single step through it first, right? You understand that. Take our time, just like we did before. And then what we're going to do is we're going to transfer this over to the real robot. So any questions? Ask now.
What is the test when you set up the input?
Yeah. Normally what we do is we set it up. We shouldn't collide here. Let me turn off I'm doing it here. So what we have the ability to do in a program is we can put comments into a program. That's been in every programming language I've ever dealt with. If you put a comment into a program and you upload it to the controller, then the controller just skips over those lines because it's not for it, it's for what? It's for you. Go back and do that. So what we have the ability to do, if y'all bring up y'all's MotoSim manual. By the way, you got 2 spots. You can log into Blackboard, but the manual's also available on this student drive. So students, robotics, manuals, Motoman, and then that's not up there. MotoSim EG. Here we go. And here's the manual there. Now this is nothing you're going to have to do. I'm just going to show you some of the things we can do, just if it ever comes up. probably going to open about 4 versions of this, guys. Down here under no, that's not what I want. Where's it? Yeah, simulating non-robot models. And these are all comments. So what we do is, so this is the way we identify a comment, is we put a apostrophe. And then when you upload this into the controller just ignores that because it considers it to be a comment. MotoSim uses this to allow us to do some neat things. We can set locations, we can move things. Another thing that we can do is we can move a model. Moves the model M1 in the CAD tree to change the parent to M2 without changing the model's location on the display. The model's position from its new parent is adjusted so that its location does not change in regards to the world. Okay. So what we can do there is we can actually, and another thing we can do is do what? I'm sorry. We can see a model, or we can do what? We can hide it. So what we could do is we could have 2 models. We could have one model with the gripper closed, and we can have the other model with the gripper open. We put it in the CAD tree, and then we do what? When we want to close the gripper, we would hide the open model and do what? Display the closed model. Another thing that we might want to do is actually transfer the block over to the gripper on our simulation, because that way it moves, right? Y'all understand that? So if we look, and this is the last thing I'm going to show you, and y'all don't have to do this. I'm just showing you some of the features that's available. Hope it lets me open up another version of this. We'll see. I think it will. So we can do stuff like this, which is pretty neat. So here, the simulation actually looks like the actual program, right? You'll see this? And if we do look at the program, let's stop it. Sorry, guys. So what did I do? So this moves the model back to the what? The floor. And this moved the model to the tool center point. So I'm actually doing what? Taking a model that was originally attached to the floor and moving it over to the gripper. And then what it does is it actually does what the real program would. I just messed up. My,
Whatever.
it messed up. We have the ability, and this, I need to bring up the other program. We have the ability to make sure, because we have little problems in that the encoder's not exactly right all the time. So what happens over time, if you run the model has a tendency to drift. So let's say we go down one time and it's, something 0.526, and the next time it's something 0.528. Well, what would happen is it would cause the model to shift a little bit. And over time, what happens is your model will actually drift because of the accuracy of the program. Does that make sense? So what we have the ability to do is reset the model location every time. And that's what that axis 6 is. So we have a command where we can, every time I open it, I can reset the model to exactly where it's supposed to be, and that way it compensates for the drift. Y'all understand what I said? Every time when we say minus 42.534, and then you go to the next corner, it might be minus 43.527, right? You understand? And so what would happen is it would cause the model, if those encoders are not exactly perfect on the simulation, it causes the model to drift, just like you saw a while ago, but that just messed up. But the program actually reset it right here, so that's where it is right there. So even though the model screwed up there for a second, here's the axis 6 right there. So what I did is I established a Cartesian location for the sign right here. So even though it jumped over there, the next time it cycled through, it went over to the right spot, which is pretty. But y'all don't have to use these. So what I'm doing is this runs a lot of different programs, and what would happen is if I don't hide models that are not part of this program, so the box is in the CAD tree. So I don't want the box to appear in here, right? You understand that? So what did I do? I hid the box. I hid the gripper with the marker. I hid the block. I put the what? Put the sign. I put gripper 4 on there. So what I did here is that even though I have 5 or 6 programs in this cell, I can do what? Yeah, I can. So if you look at the CAD tree, it's got a lot of models out here. But what I have the ability to do is use the same cell for quite a few different programs and do what? Hide the models for one program and put them in there. Now, when you upload this to Motosim, to the robot, it sees this as a comment, right? And what will it do? It'll just skip right over. So the controller don't care about comments. Every programming language I've ever programmed in gives you the ability to put comments in as part of the program. And what that does is it helps you later on remember what sections of programs do. And also it gives other people that come in and look at your program the ability to figure out what goes on. So what we're doing, the comment command, is we're doing that non-robot models, and gives us the ability to animate models that are not part of the robot. Well, it depends. Well, these are all here because what I'm doing is I'm hiding models from another program so I can show the models used by this program. So that means I can come over here and I can go to a different program. So I can come over here and I can load in another program. Let's say I want to load in job A. Well, job A don't move a sign around. So what I would like to do is I would like to come up here and hide everything that was used by this. I didn't hide the sign. I should have hid the sign. So right now, if I run this program, the sign's there. See, because I didn't do what? I didn't hide it. But I could come over here and if I stop the program now, then I could come up here. And so what I'm doing is I could come up here and I would just say hide. I think the name of it is sign. And then add a line. And then hopefully when I run it, the sign will disappear. See? So what I do is the first part of it, I do what? The first part of it, I get rid of the models for the program I don't want to run. Then I do what? Then I see the models that I want to run. And what it allows me to do is to have the same cell running a lot of different programs that use different models. Of course, I would have to go over there and set that up. This is just a program that verifies this model. So normally what we would do is when you build your model for the work cell, and y'all not going to have time to do this, I use this program to verify that you built the model correctly. So normally when we do the class, y'all actually build this thing right here. And so for some reason we didn't get to that. But that's okay. You know, the intent of the class is learning basic modeling. Y'all understand how all these models were made now, right? Y'all understand parents and attaching, and everything here was made with cylinders and squares and that kind of stuff. Y'all understand that? But the main intent of the course is for you to learn how to basically write a program or do a program on a simulation, upload it to a robot, or get a program from the robot and do what? Load it to this. And that's what we did in Lab 8. We gave y'all the program, and what did y'all do in Lab 8? Y'all that were here. You took the program, you modified it, and then you downloaded it from the robot, right? You understand. Did what? Modified it and went over there and uploaded it, and it ran it. That's the real neat features of a simulation. So what's the big advantages of simulating work cells or doing programs with a simulation?
Robot.
Number one, the robot's not down. Number two, yeah, you don't have to. You can collide your simulation, and also you can set up collision detection. You don't set up collision detection over there, right? You understand? So you can see what's going to collide if you set up collision detection correctly, and you know right off the bat that you got a problem with your what? With your program. Okay, guys, y'all got any questions here? So I would just want to show y'all the other automation or the other kind of stuff that we could use. That what?